Solving for exponential equations works like solving any other equation. If I have 5 raised to the 2x minus 1 is equal to 25, I'm looking to solve for x. Ordinarily, when dealing with non-exponential equations, it's very simple. I put everything that is not an x to the other side, and then I solve for x. Here, I have a problem where the x is an exponent. So in order to solve this, for now, I'm going to use a very basic method that will not work on every problem. However, it's going to convey the idea of what is being done to solve for exponential equations. And later on, I'm going to use a different system that will be able to solve for any exponential equations, and they're called logarithms. But for now, let me worry about solving this using the simple method. And the simple method involves making the bases equal. So what I want to do is make the bases the same. Right now this has a base of 5, and this has a base of 25. There is a simple way for me to change this to the same base. 25 is equal to 5 squared. So if I choose, I may rewrite the 25 as 5 squared, and it's the same thing. There are two equivalent numbers being expressed differently. So if I decide to express it in that way, I'm going to be left with this. And what's always important to remember anytime I'm dealing with an equation is that this is an equal sign. That means that this side is equal to this side. And here, to me, it's apparent what exactly I'm doing now. I have a base of 5 here and a base of 5 here. In order for these two things to be equal, these exponents must be equal. So what I'm looking for is an x value that will ultimately give me a 2 on this side to be equal to this 2 over here. So I can essentially ignore these bases because they are going to remain the same. What I'm looking for is the x value that's going to give me 2 on this side. So I can think of this now as 2x minus 1 is equal to 2. I am only concerning myself with the exponent because that is the only thing that is different. The bases are now the same. In order for these two things to be equal to each other, the x value must equal 2. And now I can solve this like any other equation. I can add 1 to both sides. 2x is equal to 3, and divide out by 2. X is equal to 3 over 2. And to check, I can put in 3 over 2 back into the original equation. Two times 3 over 2 is 3. So 5 raised to the 3 minus 1 is equal to 5. To the second, 3 minus 1 is 2. And I'm left with 5 squared is equal to 5 squared. So this proves that this x is equal to 3 over 2 is correct. So let me do one more example. Another basic example. Most of these simple simple solution. Most of these exponential equations that have simple solutions is really just an exercise of using the laws of exponents, or the rules of exponents, however you want to describe them as. Let's say I have 3 raised to the 2x plus 1 is equal to 243. Here's another relatively simple one. And the only real problem with these primitive methods of solving these problems is sometimes a base is not a parent equivalent base. Sometimes we'll have to change both sides in order for it to be equivalent. In this case, that is not going to be necessary. But for many people, this may not be apparently obvious, that 243 is in fact 3 times 3, which is 9, times 3, which is 27, times another 3, which is 81, and then 81 times 3 is 243. So this can be written as 3 to the 5th. And for now, until I know about logarithms, this is the only way I can solve an equation like this. And it's very inconvenient and annoying. But for now, that's all I can do. Until I learn about logarithms, which will be very soon. Thankfully. So 243 can be rewritten as 3 to the 5th. This is equal to 243. 3 is equal to 2x plus 1 is equal to 3 to the 5th. And now I have the same base. I'm looking for an x that will give me a 3 that will equal 3 to the 5th. I have 3 to the 2x plus 1. I need 2x plus 1 to equal 5. So I ignore the bases because now they are not important. 2x plus 1 is equal to 5. I subtract 1. 2x is equal to 4. Divide both sides by 2. X is equal to 2. And if I put 2 in here, it's easy to see that 2 times 2 is 4 plus 1 is 3 to the 5th. And then we have both of these sides equal to each other. So this is the answer.